Hello, everyone. Hi. Hi, guys. Please reply in chat if you can see me. Hi, guys. Can you hear me? See me? Please reply in chat. Okay, so I see almost more than 12, 13 viewers. So would it be okay to start now? Seems we are facing some problem in getting responses. Just bear with us, please. Okay, so I'll be starting. I'm sharing my screen with you, and let us begin. Okay, so today we are going to cover fundamentals of blockchain, and as we see, so blockchain is what is blockchain? That's what we are introducing in the first slide. It's a digital ledger that keeps record of all transaction that takes place on a peer-to-peer network. We will talk about all these things in the upcoming slides. Then in the second picture, you see all information transferred via blockchain is encrypted, and every occurrence recorded, meaning it cannot be altered. It is decentralized, so there's no central authority governing. Then it can be used for much more than the transfer of currency. So right now, what people assume that it is only cryptocurrencies that blockchain is used for. That is not true. So we'll talk about it in upcoming slides. Then the information is actually encrypted and can be very secure. Okay, so let me introduce myself first. So I've been working in IT for almost 14 years, and I have worked in India, North America, and APAC region as IT project manager, business analyst. So I started as a developer earlier. I've been working with branded companies like Infosys, TCS, ASG Group, and Keen Incorporates. And currently, I'm living in Hong Kong. I've been working here for almost 5 years now. I have been working in insurance almost for 6 years of my career, so I should say I have a good understanding of that. And then I have managed complex projects in web and mobile as well. So for my blockchain technology interest, I developed it last year. Since then, I have been doing some self-studies, trying to understand some papers, and then now it seems I have gained a good level of understanding of this technology from consulting perspective. So just to make clear that I am not a developer anymore now. I have not been into coding for almost 8 years now. Though I would love to code a blockchain for myself, I had tried my hands on very little, just on a very small contract that I created, but I don't find it sufficient for me to say that I am a developer. But I would like to do that in near future, developing some good contracts, a smart contract, and then creating my own blockchain. Also, I have completed some certifications, very basic level in blockchain, and I'm planning to take more bigger certifications in near future. I am a member of Blockchain Council, which is operating headquartered in California, and it is operated from India. Other than blockchain, I have a very keen interest on upcoming technologies like artificial intelligence, Internet of Things, and big data. So that's about me. So let's move on. So in the agenda, we will cover what if we know about something about history and origin of digital money, and in a brief about what money is all about, as we understand. Just to let you know, in order to understand blockchain, because it started with the inception of Bitcoin, it is important to understand money concepts as well, because Bitcoin is a digital currency, and then blockchain has been given to us by Bitcoin. So better to understand that. Then we will understand we'll talk about a bit about Bitcoin white paper and how it revealed the blockchain technology, because it is important to understand what an anonymous person wrote about this technology and invented it. Okay. Then we will talk about distributed ledger and peer-to-peer transactions and how these are carried about. In detail, we'll talk about what are transactions, how they are performed on a Bitcoin, what are nodes, what are blocks, what is nonce, a few terms about blockchain technology. We will understand a bit about smart contracts, decentralization of applications, what is mining, what is proof of work, proof of stake, and ICO. We'll just touch base upon these things because these are very wide topics and it may require maybe another session on each one of them separately. We'll talk about what are the properties of a distributed ledger on blockchain and what are the advantages, disadvantages that this technology brings up, because it's a hyped up technology and it is just in very nascent stage. It is just beginning. So we'll talk about what advantages it may give, what are the shortcomings or disadvantages that it brings along. We'll talk about some use cases, maybe on public blockchain or a private blockchain. I have put up some references for you guys to go on with them and understand them in detail, and what references I have used to put up in this document as well. Then at last we are going to have our question and answer round. I mean, probably we can take up question in last 15 minutes. So we have just blocked 1.5 hour for this session, but I'm not sure whether it's going to take 1 hour, less than 1 hour, or more than 1 hour. But whenever it ends, last 15 minutes we'll keep for question and answers. Okay, so some ground rules as we talk about. So as I said, it's a disclaimer to put up first that a lot of material in this presentation I have taken up from open source internet, and I have used it only for information purposes. So and the references and the sources of this information, I have given due credit in the references, so that there is no IPR violation, so to say. For now, we will only cover the fundamentals of blockchain technology, and we are not endorsing any ICO, any cryptocurrencies. We are not going to talk about them for now because it may be a controversial matter, so I'll stay away in this session at least. For discussion or related to the development and how the coding of blockchain application is done, and what is the technology stack, what is the database it uses, what might be the languages to be used, what are ICOs, what is cryptocurrency. I think it would require having a separate session because these topics are very wide in themselves. And before moving ahead, let me put up some ground rules as well. So I know that in this webinar, in the YouTube, you are put it in listen-in mode only. Just in order to ask a question, as I said, I have put up a Q&A session at the end of this session. You can type your questions in the chat box, and if I'm able to answer them right away, I'll try to answer them. If I'm not able to, I will note them and then I'll get back to you in the Blockchain India Telegram group. And you can also contact me on the contacts that I have provided in this deck later on. And then you can right away test if you want to say something in the chat box, though I tried to test it in the beginning, but we couldn't get any of the response. Anyways, to we keep that aside, and then we'll start with our presentation, and we will understand what is money. Okay, so what is money? So money is something, and money is anything which I can use for the exchange of any goods and services. Okay, so I can buy anything. I want to buy, let's say I want to buy a bicycle, and then I give anything to you in return. That can be termed as money. Okay, or if I have borrowed something from you and I can return it back to you, that is money for definition perspective. So earlier in olden days, it was actually it was valuable metals. We'll talk about it bit about the history of money, and people used to use those valuable metals or materials to exchange good for them. Okay, so anything which is having a value can be termed as money, and our all modern systems are actually based on fiat money, which means it has got some intrinsic value. Okay, the term for money is derived from a Latin term, meaning "let it be done." That's what the meaning for it. So it shall be money. That's how they call it in Latin. Okay, so as I said, it can be a medium of exchange. So you can get things for in lieu of money. You can put up your account. You can put it up in your account. So gold, if I talk about gold, you can store it somewhere in your vault. So you can and you can use it for calculations. So 1 penny of gold, 1 penny of silver. That's how you can put it into your accounting, and then you can store it. That's what money is all about. So just to give you a context, we are talking about money because we want to understand what Bitcoin is, and then based on the Bitcoin, we want to understand what technology it brings along. Okay, so we need to understand this concept because we need to understand the white paper. So money is whatever is generally accepted in exchange for goods and services, accepted not as an object to be consumed, but as an object that represents a temporary abode of purchasing power to be used for buying still other goods and services. This is quoted by Milton Friedman, who was a Nobel laureate and a well-acclaimed economist from United States. So that's what gives about the definition of money. So I will if required, I mean, if you are interested, I have a real interesting timeline infographic by mint.com, which was created for money. I will go upon it later on when if it is required to understand more about money. Okay, so history and origin of money. So in the ancient system, if you can see on the screen right now, there were even before Christ, there was money concept. So in terms, it is very old. So they used to have these coins created from different metals. So you can see the silver that was used from 700 to 550 BC. Then there are other metals which are used in Roman times as well as Malaysian times as well. So so there were 3 great empires as we talk about. It was Babylon, Greece, and Rome, and they created the money based upon their natural resources. So whatever is available, that only we can exchange. So the Babylon Empire used gold, which was very commonly found at those days, even in the rivers. So you jump into the river and you get some gold out of it. Not possible these days though. So, and then during Greeks' time, they had silver coins, and then you see in the Romans' time, they had like other metals they were using in the as bronze, and then over the period of time it kept on changing. So it kept on changing, and then it emerged. So after that, it came as like instead of coins, people started changing even the grains, even the vegetables, livestock, like sheep and goats for their for buying other things. So that system was known as barter system. So they used to exchange for whatever they want to buy. They used to exchange their livestock. They used to exchange their grains. So whatever they were farming. And then later on, it was indirectly medium of exchange. So they were like even the skin coins that were created, leather coins that were created in between. And then finally, it emerged as our paper money. Okay, so as I said, it's derived from the Latin word, which is known as monet. When it was originated, nobody knows it. Okay, so we don't know when people started this exchange system. So as I said, skin of wild animals also was used as money. Then livestock was used. Agricultural society used grains and foods, and Romans used cattle and salt as well. Okay, so what is the need for digital money now? So now we are in digital age. Just before moving on to digital age, just to let you know that even our fiat currencies, the paper money, was not invented long ago. And it was initially designed to have an intrinsic value against the precious metals only. So the fiat currencies that we are using, like even the dollars or the rupees, they were supposed to have backing by the gold. So it was called gold standard for the banks. But we'll talk about it more as we go on. So right now, our economic transaction that are taking place electronically to reduce the burden. Okay, so that I don't have to go physically to give money to someone, and we are exchanging our money in the form of bits and bytes. So that's why. So if you know, we are using a lot of smart cards, a lot of payment systems like PayPal, Paytm, and we are using these things just to transfer money from here to there. So actually, it's not money transfer; it's just a value transfer that is done from one vendor to another. That's what we are doing. Okay, so instead of what convenience it brings to us is that I don't need to carry money in my pockets or in my bags and give it to someone, and easily I can send money across and make payments to anyone across the world right now. So as I talked about a little bit about the payment vendors, like in 1998, PayPal started. And right now, it's a little bit old data, maybe a year or so old, but you can assume it to be a little more than that. But if you see, it's like $47 billion of market capitalization that PayPal is having. In 2008, Bitcoin started. The current market cap we can see on CoinMarketCap, but it is telling us to be 7 billion, which is like last year almost. Square, that is another payment system, which is like 5 billion, which is started in 2009 and 2011. Blockchain is a payment system which started, which was given to us through Bitcoin. It's old data, but right now it seems the blockchain transactions are around of the size of like almost 1 billion or more than that. Okay, so so if you see the power that blockchain payments are carrying, it's increasing day by day, and any payment system is increasing in revenue very fast. Okay, so that's what we talked about. So when internet came, they had already started to figure out how we can send across money digitally. So I can say, I mean, almost in 70s, internet was discovered. Actually, it was discovered during World War II, but that was a communication only between the militaries. But later on, when it came out for commercial use, like in 70s or something, then some scientists or like very high state of the art technologists started to use internet. Then it became public, which was, I believe, late 70s or early 80s, and it started to gain maybe in around 90s too much when like common masses started to adopt it. But the payments, the trial for payments had started like in late 70s already. Okay, so there were scientists who were working on creating e-payments possible, but there were a lot of problems they were facing. And then the first attempt was made by DigiCash in 1992 by cryptographer David Chaum. So you see, the cryptography is in existence almost since when the computer age has started. Okay, so David Chaum started this company named DigiCash in 1992. By mid 1990s, there were several private companies who tried to create electronic cash system and facilitating these e-payments. But a central regulator was always required. So if you see, I have highlighted that in bold because any payment system till now, still it requires a central regulator. So there was a central regulator required to authorize the transactions. And also these regulators, they will ask you for your identity for everything. So it will never allow any anonymity to do the transaction. When I come to anonymity, I mean, I really don't advocate that because it may bring in many problems to the society. But still, when we are talking about a use case for blockchain, anonymity is also a use case of blockchain. Okay. So when we're talking about mid 90s, the credit card payments via the internet, people were afraid of using them, and they were very skeptical, very apprehensive about their money security. So that was a big problem, and then it was not letting e-commerce flourish or getting enabled and globally. So that was a problem. Then there was an obstacle, which was very primary obstacle in the business world. If you see, we all need a trusted middleman. I think even in today's world, there are many people who don't believe in paying money unless they have a trusted person in between. Okay, so all these systems till their late 90s, they could not solve this problem. And then the another biggest problem was that because all these systems were centralized, there was always a problem of single point of failure. So if my server is down today, I am a payment vendor, and then nobody can make payment through myself, so to my system. So it's a single point of failure. Okay, by late 1990s and early 21st century, Visa and MasterCard, it had gained a lot of momentum. These companies had gained, and then and there were a lot of technical difficulties that they had already sorted out, and people started to trust them. And then now in this world, we see after 10 or 12 or 15 or 18 years, we are using our credit cards like fearlessly, So moving ahead, so now what about Bitcoin and digital money? So digital money, in brief, we talked about a bit. and we understood that our plastic cards that we use right now, whether it is Visa, MasterCard, American Express, Union, TransPay, or whatever, are all now trusted source, and there are a lot of people throughout the world making these transactions. So what Bitcoin brings to us and how blockchain is revealed. So as I said that for creating digital currency, there were a lot of numerous efforts that were made in previous decade, but a standalone digital currency was never realized. Okay, so almost for a decade, they could not understand how they can reach a purely digital currency, which is like only dealt with on the in the virtual world, and it is not there existing in our physical world. Okay, so a practical digital currency design was actually revealed by a mysterious person in year 2009, and it did not rely on a central third party. So as I said, the trusted middleman was gone. So Satoshi Nakamoto, that's the name of that mysterious person. Nobody knows who he is, or is it a group of people, or it's just a single person, or two guys, or it's a company. Nobody knows, but they anonymously sent to higher officials of Wall Street. They sent this white paper on digital currency, and it was termed as Bitcoin. So it was neither a company, not a product, but it was just a white paper which was describing the set of rules for a digital currency. So what it contained, that letter, it contained the white paper, it contained that a protocol that was dictating how digital transactions should be handled. If anybody's followed the rules, there can be any person who can follow these rules and use this digital currency, and not a single person would be there who will be owning these rules, or singularly he can change these rules. No, it's not possible. So that's what it is saying. So, and there was no central third party. I'll talk about these things in detail in upcoming slides, because right now it may not be understandable, because how a central third party is not there, who will control? There can be a lot of questions like that. So when there's no central third party involved, there's no single point of failure there. There's no ownership to it, and it's shared responsibility with whoever is participating. So this is one of the disadvantage, so to say, that not a single individual that can be charged with money laundering, if you can say. Okay, now the biggest thing is that no individual, or not a government, I will say again, can shut down the system. As long as there is one person in this world which is running a single node for Bitcoin mining software, this system will continue. So if you think that any government, maybe from the United States or from India or from Hong Kong or China, can stop Bitcoin, they cannot, because Bitcoin participants are there all over the world, and they are running the nodes. So participant, when I say they are miners, I'll talk about miners later on, but miners are there, and nobody knows how many miners are there. And even if a single node they are able to run in a lost place, in a lost island, then also Bitcoin blockchain will run. So no single government can stop it. It can only be stopped if the whole internet from this world is stopped. Okay, moving ahead. So Satoshi Nakamoto, there have been FBI raids on different people in the United States, but they charged some of the people. They They tried to put them behind bars, but actually nobody could reveal the identity of Satoshi Nakamoto. We don't know he's alive or he is dead, but it is said that he was living in Japan when he sent this paper, and sorry. Some of the people say that he must have died by now, but nobody knows. It's only speculation, or nobody knows it's a real name also, or a real person. So on August 15, 2008, there was a patent that was filed, okay, and for the Bitcoin concept. And in August 18, so you see, so fast they registered Bitcoin.org, so that government doesn't have time to understand and react upon what they are publishing, what they are trying to do. They already launched the blockchain. And then it's running since then. Okay, so moving ahead. So more on white paper and blockchain revolution. So in the white paper published by Satoshi Nakamoto in 2008, it was first time when blockchain technology was introduced to the world. I have given the white paper link in the appendix of this deck, so you can go and find out the white paper and read for yourself. There are many rules and a big time algorithm which is given for digital currency to understand and how it will work. So you can go through it later on. And then this digital payment system was designed to perform peer-to-peer transaction in a secured manner. So when you will go through this white paper, you will understand what I'm talking about in detail. But just to give you an idea, in a nutshell, it will perform peer-to-peer transaction in a very secured manner. So from definition point of view, Bitcoin is an open source. Okay, so open source, it is open to all because it is available on internet. It's peer-to-peer, so I can transfer money to anybody who's listening to me right now, and nobody may come to know. It's only the transaction can be traced upon blockchain. But if I have not supplied my ID on the blockchain or to my wallet wallet vendor, nobody will come to know that I have transferred money to any other person in this world. It's digital because it can be used through any digital application or appliance. We can use it through mobile, use it through web portals or any tablet or anywhere. It is decentralized, as I said. Not a single person is controlling it. So there are nodes, there are participant nodes who controls it. So it's very much decentralized, and it is powered by blockchain technology. So that's the definition, standard definition, which is from blockchain.info. If you want to read more about it. So defining characteristics, as I said, it's decentralization. There's no central governing authority, no central bank, no Ministry of Finance. In fact, the website which is run like blockchain.org or bitcoin.org, that website is run by a society, group of people. It's not controlled by one person. So there's no CEO of Bitcoin who can make a decision all of a sudden and say Bitcoin is closed today. So I'm only talking about Bitcoin. Please don't confuse it with other altcoins. There are many altcoins which can shut down their system in one day. So it's only about Bitcoin when we are talking in this presentation. So, and all the issuance of the Bitcoin and circulation are only controlled and regularized by the users, which are known as miners. And point to note is that there is no single miner. There are lot many miners in this world, and there's no exact count of it because there are some people who are anonymously mining. Okay, so and Bitcoin can be sent anywhere, anytime, with very less fee for the miners. We will talk about it later on. There are transaction charges, but they are way too less than what we pay today to transfer money from one corner of the world to the other corner. And then it disregards national borders or any government or bank, which I like most because I don't like boundaries. Okay. All right, so how it works, let us see. So Bob is there who wants to purchase something from Joe's store. Okay, using Bitcoin, of course, from his Bitcoin wallet, you can see here. Joe's store provides Bob with a unique address to send the payment to. So that is the Joe's store wallet address, and that wallet address is used by Bob to send the amount using this unique address. Okay, and then sorry, my bad. Yeah, and then this transaction goes to miners on the blockchain. Miners verify it, authorizes it, and then Joe's store receives the payment in Bitcoins, and finally the transaction is recorded in blockchain. So it's as simple as that. I can actually map it to the real world where I want to buy something from a store. I have to have that store's address. I need to carry money in my wallet. I go to the store. I ask for the item I want from that store. I pay the money from my wallet. Because I know the address, I am already in that store. I pay from my wallet. As soon as I pay from my wallet, the shopkeeper gives me the item, but the transaction is nowhere recorded. So here, our transaction is getting recorded. So if in an imaginary world, if everybody starts to use blockchain for their transaction, which means every single transaction of the world would get recorded. There will be no cash system. There will always be a traceability of all financial transaction in this world. So, so that's an advantage I can think of. But those transactions can be anonymous. That's a disadvantage as well. So we'll talk about them later. Let us move ahead. So let us leave Bitcoin's topic and payment transactions topic aside and come to our main agenda of talking about our blockchain. Okay, blockchain technology. Okay, so what is blockchain technology? So blockchain technology, as you might have understood by now, it's a ledger. It's a public ledger that will record each and every transaction that has been performed in the network. So the technology is given to us by Bitcoin, though, but it is in itself it's unique because it's recording everything that is done on the network. Okay, so I'll talk about ledger. Maybe you might not be able to relate it, but very soon you will be. So blockchain records these transactions in the same way as a banking ledger records plus and minuses in a book. So some of you might be from accounting background, but even if you are not, then also you might have seen some Excel sheets in your day-to-day work in which you are recording transactions, and in order to keep the balance of your debits and credits, which are pluses and minuses, you need to record each transaction, and finally you submit for your balance. So it's a kind of, a ledger is a kind of balance sheet which records your debit and credit transactions. And blockchain also does that same way, but there are some exceptions. The exceptions are that it is doing it with recorded digital transfer of ownership, and it is recording into the network. So I cannot make a transaction unless I have a unique address that comes from my wallet usually. So it is recording it digitally. So I know that the transaction is being performed from point A to point B. Point A is unique, point B is unique. So I can identify a transaction end to end with unique ownership. And Excel will not do that. A practical ledger in accounting will not do that. Any participating computer in the network has a recorded document of the digital transfer that takes place. So any node which is participating through mining or user of the blockchain, they record this. Okay. So how everybody does that, we'll talk about later on in upcoming slides. These participating computers are called nodes. These nodes may be one of the blockchain miner nodes or just a simple user nodes. So I can get a copy of blockchain on my system, and I can be a user node without performing mining. I may authorize other things like the code change or something, or maybe a fork. We'll talk. I mean, these are different topics about the blockchain, but just to understand, the user can also participate in the blockchain. Miner anyways does, because miner authorizes the transactions and verifies them. Okay, most blockchains follow the Bitcoin protocol, and every 10 minutes the blockchain ledger is updated by every computer in the system for the data or transaction. So it's like almost everybody, all the blockchains that are currently there in the world, they have either derived from Bitcoin blockchain or somehow Bitcoin protocol they are following. Okay, in a way or other. There are, like, if I talk about Ethereum, also it has derived from Bitcoin protocol only. It is a derivation of it. Or I talk about EOS, or I talk about any other blockchain. For now, it is derived from Bitcoin protocol. In fact, industrial blockchains are also using the same white paper to derive their blockchains, which was used for Bitcoin. Okay, so important is that a Bitcoin protocol uses transactions to be ledger to be updated every 10 minutes for all transactions for all computers in the system. Another example that I am giving using explaining the blockchain and mining. So you see, A wants to send some money to B using Bitcoin wallet or any other currency wallet. The transaction is represented online as a block. Okay, so every transaction that is performed on a blockchain, it is referred as a block on the blockchain. It can be a group of transactions also, but for now simplicity, we'll take that. Okay, each transaction is a block. Then this block is broadcasted to every node, every miner, every user in the network. Okay, then those who are available in the network, like those who are online, they can pick the transaction and validate it and authorize it. Okay, so in order to do authorization of transaction, there is a lot of work to do. We will talk about it later on in the coming slide. And then after authorization, this block is approved to be added to the chain, and it cannot be edited. It's indelible and transparent. It can never be edited on a blockchain in the record, that particular record. Okay, And then once the block is created, that transaction is recorded, the money moves from A to B. And that's how a simple blockchain would work. Let us go a little deep into distributed ledger and P2P transactions. So as I said, what is a simple ledger? So a simple ledger, by definition, is a book of record keeping of all the financial transaction of the organization. I'm talking about financial transaction. It can be any transaction. You can keep a book of anything to record anything. So when we were in schools and colleges, we used to call it as a register. So even the attendance register can be referred to as a ledger, because it used to record the attendance of the students in the class. For easy reference, we can answer it as an Excel containing the records for debits and credits from a bank account. So if I want to trace, so if you see your bank account statement, that is showing you all debits and credits from your bank account. So that's a ledger of your account. So that's how a simple ledger is. Anything which is accounted in simple ledger. So what's a distributed ledger? So a distributed ledger shares the copy of the ledger with each and every participant of the network. So as we saw in blockchain, whoever is participating, a distributed ledger has a copy of it. That participant has a copy of that ledger. That's why it is distributed. So each transaction in that ledger can be viewed by all. It can be securely copied by all, and it can be verified by all of the participants. Okay. Once it is verified, the encrypted transaction is recorded in the encrypted blocks. So that's where security comes in. This information is available in the ledger for everyone to view using public keys. Even I can view, even if I'm not participating in the blockchain, I can take that key. If I have that public key, I can go and see that transaction in the blockchain. A transaction once recorded can never be altered or modified. I'll explain why, but for now it cannot be altered anyways, because it will be too difficult task to do it to be done. A new transaction can't be recorded unless approved by the nodes or miners. So that's the difference between centralized and distributed ledger. You see a bank in between or a clearing house in between, like I say RBI for India, Reserve Bank of India, or any central bank. That's a clearing house for all the transactions. So I make a transaction, and then this transaction is sent across to all parties, all stakeholders which are there. So there is a central repository of these transactions. There is a single point of failure that can occur. In the distributed ledger, you see any transaction is recorded by all participants. Okay, it can be retrieved from any of the stakeholder, and there is no central authority governing it. That's the difference. So everyone in the network, if you see, like there are 8 instances, everybody is having a copy of transaction. How it works, blockchain. So as we saw in previous slides, it can be understood in simple terms as a digital distributed ledger, or it can be thought of as a spreadsheet containing multiple records, multiple transactions, so to say. The blockchain ledger comprises a constantly growing list of transactions called blocks. So we already saw what a block is, and all of these blocks are sequentially connected using unique keys, and that's how we coin the term blockchain. Okay, so each block has a link to the previous one in the list. Once a block in the chain is created, it cannot be removed. So it goes and sits into a permanent database, containing all the transactions that have occurred since its inception. So the block which is created on the inception, so the first transaction on the blockchain is known as Genesis block. Okay, so it's a well-known term in blockchain industry or technology. Blockchain ledger has no central authority, no single source. It's there on all participating nodes. It means every node has got its own complete copy of blockchain all the time. As and when there are new blocks added, they are also received by all participants. So distributed consensus and trust ensures that the system is integrated. So let us say I am a participant, of the blockchain, I am a node, I'm having a node, and my node goes offline. I need not worry. Whenever it comes online, it will take its copy of blockchain from some other node. So I will again have a fresh copy of blockchain. So I hope you all understand. So it's also, blockchain is called Internet 3.0. That's because it is going to revolutionize how transactions happen on internet and how it is recorded. So from the definition perspective, if I see, blockchain technology typically refers to transparent, because it can be seen by anybody. Trustless when I say, because I don't need to trust anyone. So I'm doing a transaction as long as it is verified and authorized to be by the miners to be having a valid node where I'm transacting. I don't need to trust that person. Okay, so as long as he has a wallet which is verified by mining, it's trustless. When I talk about payments, it can be little debatable when it comes to payments. But when it comes to industrial use, I don't need to trust, because need to have a trusted middle party, because I trust all the nodes that are participating in my network, right? It is secure. Why it is secure? Because it's using cryptography, encryption to multiple layers. And a block or a transaction can only be retrieved if we have the combination of all those encrypted keys. So which is like your public keys. If you have, then only you can see that transaction, and you can only alter that transaction when you have private keys. So it is secure, it is immutable. I'll talk about immutable in a while. So transparent, trustless, secure, immutable, publicly accessible ledger using distributed ledger technology. That's what a blockchain definition would be. So same thing which I told earlier in a little detail. So A wants to send money to B. The transaction is represented by a block. On number 3, the block is broadcasted to everyone. Block is broadcasted to everyone in the network. Within a few minutes, majority of parties in the network validate this transaction. Then finally the block is added and the transaction is complete. Little more in detail we go. Okay, so how a traditional transaction system works. In the bank, if I may want to make a transaction, there will be a bank which will be verifying my transaction. There will be a third party like central bank which will be approving it, and then finally the transaction will be done. But in the blockchain system, that middleman, that trusted middleman, is replaced by the blockchain itself, because blockchain is doing the approval and authorization of the transaction. Okay, so and as I said, it will record every transaction that is taking place, even for a single penny. Okay, so to understand how it works in a better way, let us understand the hashing algorithm with the help of an example. So when I say encryption, okay, so encryption comes through this hashing algorithm. The security comes through this, okay. So for example, if I say, let us say A wants to pay B for certain services rendered, and both have got cryptocurrency wallets in their smartphones, and they can access the blockchain, but does not identify the user to the system. Okay, so wallet doesn't require your ID; it just use smartphone. In a way, it is controversial because you can say a smartphone is my ID. Yes, but in a way, you can maintain your anonymity because there are a lot of technologies who can mask your identity. Okay, the transaction starts with A's wallet proposing that the blockchain be changed so as to show A's wallet sending the money to B's wallet. So the start of transaction goes from A. Okay, so transaction starts from A, and it wants to change the blockchain so that A is sending money to B. So how hashing is working on that? So what happens to the transaction, that we'll see. So the network goes through a number of steps to confirm this change. Okay, as the proposal propagates, so what happens? Various nodes, mining nodes, check by inspecting the ledger. So what miners do, they check the ledger. They verify whether A has sufficient amount to send to B, and they verify there is no previous similar exactly same transaction, duplicate transaction. Even if there is a duplicate, they verify if the money is sufficient, and then if everything is looking fine to them, the nodes, which are called miners, will bundle A's proposal with other similar reputable transactions, and the new block will be created. So what will they will do? There's one transaction. As I said, a block can be a group of transaction. What happens? Transaction is given a hash value. So this hash is figured by computing. Okay, and then this hash value, all the transaction, it is attached to all the transaction. Some of the similar transactions are clubbed. They are given another hash value. So you see there are another level of encryption there, and then those transactions are used to create a block giving another combined hash value. So you see the level of encryption there, and then finally that block is created. This whole transaction tree is known as Merkle tree in technical terms. So that's how a block is created. A timestamp or a nonce is added to it so that it is uniquely identified in the database. So a block number is assigned to it. All the hashes of combined transaction plus the timestamp and a nonce. So what is a nonce? Nonce is termed as a unique number. So nonce is never used once. That's a unique number. So it is never used earlier and not going to be used in future. Okay. So that's how a transaction or a group of transaction is performed and a block is formed. So just to read out, each transaction in the set that makes up a block is fed through a program that creates an encrypted code known as the hash value. Hash values are further combined in a system known as a Merkle tree. The result of all this hashing goes into the block's header, along with a hash of previous block's header and a timestamp. The header then becomes part of a cryptographic puzzle solved by manipulating a participating nodes. Okay, so this is the task. So I'll talk about proof of work. This is all the work that miners do. Okay, so they solve this puzzle to get this unique nonce. Once a solution is found to the puzzle, then the new block is added to the blockchain. Okay, moving ahead. So in this example, as I explained in previous slide as well, to creation of a new node, it's new block. It requires repeatedly feeding the data through a cryptographic hash function, which in turn creates a string of digits of a given length. So its hash is nothing but a fixed length string. So you give it any data you give it of any length, the output will always be a fixed length string, that is hashing function. The hash does not contain the data, but it is still unique to each of the transactions. So that's a unique string given to each of the transaction. So it is not having any data. It's just the identifier to the transaction, and it is unique to every transaction. For even a very small change in data, like adding a dot, another unique different hash would be generated. So you see, you alter any length of data, you add anything, you subtract even a single dot from it, there'll be another unique number created by hashing. Header of the proposed block for each transaction contains this hash along with some other data. So for a transaction or group of transaction, whatever a hash is created, that is stored in the header of the data of those transactions. So if I look at the database perspective, the transactions are stored in database, but when we are accessing the transaction through blockchain, it is the header that is accessed first, which is a key to the transaction. So unless I know the matching key to that header, I cannot reach to that transaction. So that's how this security aspect of blockchain comes in. So there is a multiple level of hashing done, and it can be opened for viewing only using my public key, and it can be opened for editing only using my private key. Okay. Okay, so then moving ahead, the header now becomes the basis for solving a mathematical puzzle. So a mathematical puzzle to get a nonce for this particular header, because we need to need a unique identifier for this header as well. Then this puzzle will be solved by miner. Okay, and this puzzle is only be solved by using the computing power. Okay, so the miner is nothing but a machine using highly complex mathematical operations to solve this puzzle to get the nonce, so that it can be added to the header of the block. Across the network, miners grind through trillions and trillions of possibilities and tries for the answer. So they solve this puzzle by many permutation and combination. And then when a miner finally comes up with a solution, other nodes quickly verify it. So you see, there is a verification also. It's not only finding the nonce, you need to verify. So verifying is harder than getting the nonce. The solving the puzzle is hard, but checking is easy. Sorry, verification is easier. So they do it, and each node that confirms the solution updates the blockchain accordingly. So these are the participants of those transactions or to create that block. And whenever a block is generated, so from cryptocurrency perspective, from Bitcoin perspective, if I see, whenever a block is generated, as a reward, there are some Bitcoins generated. And those Bitcoins are given to the miners who have either solved the puzzle or have verified the outcome, verified the nonce. So that's why miners have to compete with each other to get that nonce. And this is, in nutshell, this is called proof of work. That's what miners' proof of work is. Okay. The hash of the header becomes new blocks identifying the string, and that block is now part of the ledger as a payment, A's payment to B, and all other transactions the block contains are confirmed. So all of the transactions are confirmed, block is created. So that's the same diagram which we had in the previous slide. Just to explain, I went through this slide. Okay. So what are the properties of blockchain? Okay, the puzzle stage, as explained in our previous example, introduce 3 properties to blockchain. Transparency. You cannot predict which miner will solve a puzzle, and so you cannot predict who will get to update the blockchain at any given time. This makes cheating hard. Also, historical records can be verified by any miner at any point of time. So, who will solve the puzzle? Nobody knows. Everybody is trying. So, which means everybody needs to have access to the puzzle, to the verification, all miners. And then who will get to verify that the nonce which is created by solving the puzzle is correct? We never know, because it is a pooling that happens on the blockchain, and any miner can pick that task, and he can accomplish it. So it's a transparency. Everybody needs to have access. It is secure. So this is achieved. The security is achieved due to the way transaction history is recorded. So as I told you, so each new header contains a hash of the previous block's header, which in turn contains a hash of the header before it. So as I told that it is a chain that creates. So every header of the block also contains the unique key for the previous header, and every future block will contain the unique key for this new header. Okay, so in a way, all these blocks are forming a chain right from the Genesis block, and it is this constant concatenation that makes the blocks into a chain, and it is this hashing and that makes it secure. It is immutable. Now you imagine if I want to change something in blockchain, can I do it? So let us assume we are working currently on block 10, and I want to alter a transaction in block 10. Can I do it? I can do it, yes. But by the time I will go and edit the transaction and commit it on the blockchain by another node, there will be new blocks created. Block or number of blocks would be created. So the copy of my blockchain, which I'm trying to alter, okay, it will be different from the current blockchain on other nodes. Now, when I try to sync my blockchain with others' blockchain, which is only giving block number 10, then people will see, the miners will see there are block 11 and 12 already created. They will reject this transaction. So either my computation needs to be so fast that I beat everyone else on the network before any next block is created, or I cannot do it. Okay, so practically it is feasible, but it requires a very high computational power sorry, which should be higher than the best of the best machines which other miners are using. Just give me a minute. Yeah. So it requires either a very high computing power, more than best machines, which is practically not feasible, because if my company is so powerful, I can buy a high power computation machine, then there can be another powerful company which can buy the same machine or hire a better machine than me. So practically, it's not going to be feasible. This is called 51% problem. So practically, this 51% stake cannot be achieved. So that's why blockchain is immutable. So it's the same example which is given in this slide as well. So if A wants to alter the transaction done, by the time A would be able to do so, other network users would have created new blocks. All right, so it is not possible, it would get rejected. Other properties that we have already talked about. Decentralized. There's no central authority. There's no middleman required. So blockchain works as the authority governing every transaction. Public. It is public to all. Everybody on the blockchain can go and view any transaction if they have the key and view it and see it. It's available. It is programmable. So we have not talked so far about smart contracts. This is where it comes into picture. We can write a code which will be governing the rules for transactions to be created in a smart contract, which is nothing but a program written in one of the high-level language. And we can govern all the rules that would create this transaction and make it eligible to be stored on a blockchain. So it's programmable. It can be either private or public. So blockchains, there are private blockchains, there are public blockchains. So it can be secured through your keys, using your keys and using your encryptions. You can very well make a private blockchain, and you can give access rights to people within your organization, or you can make a public chain which is visible to all, like a Bitcoin blockchain. And it is trustless. I already talked about trustless. So blockchain is disrupting trust. So I just in a few minutes, if I can tell, actually, when we talk about 20th century or 19th century, the motor was invented, but motor invented and it disrupted the way we used to commute. Okay, then internet invented and it disrupted the way we used to communicate. Now blockchain is going to disrupt the way we used to trust in business. I hope you're following me. I'm moving on. All right. So what are the terminologies that we use in blockchain? Quickly, I'll go through them because there are a lot of them and I cannot talk because of the time constraint about everything. So address is a cryptographic address which is given to each of the net transaction that is represented, or each of the participating node or user. It can be your wallet address as well. Mining, as I explained, it is the work that is done by the participants of the blockchain. Private key is a string of data again, which is usually 26 character in length, and it can be treated as a password for your wallet. Okay, so the blockchain opens to you when you use this password. I mean, restricted to your usage. I mean, how much you can use it. Blockchain, as I know, it's a chain of blocks that are created through group of transactions, and it's a distributed ledger. Multi-signature, so the wallets that are created to perform a transaction on blockchain, it can be single signature or it can be multi-signature. Multi-signature, when I say, there can be 3 people owning the same wallet, and the wallet will open for transaction only when all 3 keys for the participant is supplied to it. So it may happen there are three partners in owning one wallet, and that wallet can only be opened when all 3 partners give their private keys to it. Unpermissioned ledgers, it's same as private blockchain. You cannot. It's like you cannot alter the transactions which are given there, and you can secure them. Basically, you cannot allow participant to alter the transactions there. Bitcoin, since it's a public blockchain, it is unpermissioned. Unpermissioned, not to view. It's permission to view, but it's unpermissioned to alter. Okay. Cryptocurrency, so any digital currency which uses mathematical algorithms like Bitcoin can be termed as cryptocurrency. P2P is nothing but peer-to-peer in a decentralized interactions, okay, between two parties. I think you all know what P2P is because you might have used torrent earlier, and torrent used to have peer-to-peer file exchange. So it used to be, usually we used to get movies from other guys using torrent. Smart contracts is nothing but a program written on a blockchain to govern the rules of creating the transactions as well as blocks on the blockchain. Distributed ledger, as I explained, it's a ledger which is distributed to all parties, all stakeholders, all participants of a network, and it can be permissioned or unpermissioned distributed ledger. You can block it as well. Okay, permissioned ledger is which is have permission when everybody has permission to access that ledger and edit it and add a record, modify it. Okay, so it can be used. If I see, it can be used as an example for a consortium of banks, which allows a transaction on blockchain, and they can alter their transactions whenever they want. Okay. Other terms that are used are hash rate. Hash rate is the speed at which transactions are hashed by the mining machines. A higher hash rate is better when mining, as it increases your opportunity of finding the next block and receiving the reward. So there is a war going on in all the companies to create the machines which are having very high hash rate, so that mining can be very fast. So higher hash rate is required for doing minings and gaining your cryptocurrencies as well, like Bitcoin. Nonce, as I say, number or address, which is used only once and never used again, to segregate duplicate records. So to make sure there are no duplicate records, we use nonce. dApps are decentralized apps. So any application created using blockchain as a transaction storage is known as dApp. And then TPS, which is transaction per second, which is the speed of blockchain ecosystem. So how many transactions a blockchain can perform per second. Proof of work versus proof of stake. So proof of work is the amount of computation performed by the miner in the network for getting the mining rewards. So as I told you, they have to prove that they have done some work, and what work they do, they authorize, they validate, and they solve the puzzle in order to approve the transaction. That's what they do. That's what is known as proof of work. Proof of stake is how much assets you are owning in the blockchain. So it can be a cryptocurrency. So like, for example, if I say EOS, which is a cryptocurrency, or Tezos, which is a cryptocurrency, uses proof of stake method. Ethereum used to have proof of work method, but has recently moved from proof of work to proof of stake. So you see, proof of work is a requirement to define an expensive computer calculation, also called mining. A reward is given to the first miner who solves each block's problem. Network miners that compete to find a solution for the mathematical problem, is similar reward is given to them as well. That is proof of work. So they do work. So in order to dig the gold from the mine, you need to do some work, right? So in order to dig the Bitcoin from blockchain, you need to do some work as well. Proof of stake. So the creator of the new block is chosen in a deterministic way, depending on its wealth. So whoever is having more coins on the platform, or whoever is given more stake, more wealth on the platform, he is the creator of new block. The POS system, there is no block reward, so the miners take the transaction fees. So you are seeing this sign 51%. It's actually 51% problem that I talked about. So can anyone alter? No. In both of the methods, no one can alter this. Okay, so It's cost effective. Proof of stake. It's cost effective because you don't need proof of work. So there is no work required. When there's no work, there's no mining. When there's no mining, there's less electricity consumed, less hash power consumed, and less electricity means less cost. Advantages and disadvantages. What are the advantages? So empowered users. So users are in control of all their information transaction because I have my private keys. So I can control very high quality data. So it's complete, consistent, timely, accurate, and widely available. Cannot be altered, right? Durability, reliability, and longevity. So decentralized network it is. So it does not have a center point of failure, single point of failure, and it can withstand malicious attacks. So if somebody says blockchain is hacked, then it's a spam. Okay, it's not correct. It's a scam, I would say. Okay, so blockchain can never be hacked. It is the platform which is running that blockchain or which is accessing that blockchain can be hacked. So you might have heard that a lot of exchanges gets hacked. Those exchanges are not blockchain. Those are just simple applications. Blockchain cannot be hacked. Okay, integrity. So users can trust that transaction, that it will be executed exactly as the protocol is there. Okay, and because there is no need for third party. Transparency and immutability. So changes to public blockchains are publicly viewable by all parties and are transparent, and all transactions are immutable, meaning they cannot be altered. Ecosystem simplification. With all transactions being added to a single public ledger, it reduces the clutter. Okay, so if you have worked in any of the organization, you see there are multiple applications which are accessing. Sometimes there are multiple databases also in the organization. So if I create a blockchain for whole organization and I put all my transactions, all my data over there, all my applications can use it. So I mean, like it's like I can compare it to a factory in which different machines are accessing conveyor belt, and I can put anything on that conveyor belt. So a blockchain I can definitely compare to that conveyor belt on which it just keeps on moving, and every application can take whatever it wants and can put whatever it wants on it, right? So for an organization, if I see from the ecosystem perspective, it's very easy design that we can do, that all data sits on the blockchain and all applications within the organization are using the data. So you see, almost every industry has a use case for it. Okay, faster transaction, with the more giga hash rate, coming up, we are more and more faster transaction. So it depends upon your multiple factors, internet speed as well, but the transaction can be really faster because it can be settled later on. It can be stored right now, it can be settled later on. Lower transaction costs. So there's no third party, there's no extra cost. So if I transfer money from United States to India, the banks charges me fees, and then they charges me conversion. Lot of money I pay to send the money. But if I'm on a blockchain and I'm transferring a Bitcoin, just I need to pay the miner fee to the miners, and then I'm done. Disadvantages. It's very nascent. So they're still fighting for resolving some challenges, like what the transaction speed, how it can be improved, verification process, the data limits. More and more they are resolving it, and I believe right now they are talking about blockchain 3.0 already. So it's improving every other day, and it's going to be adopted very soon. So regulation, it's very important because many countries are staying away. Actually, I would say countries are not staying away from blockchain. They are staying away from cryptocurrencies or ICOs because they don't know what to do. So they are trying to understand, and once they understand, they will adopt it probably. But blockchain, they are doing research. There are companies who are doing research. There are governments who are doing research, and they want to adopt it, and they are eager to adopt it. There are already applications which are being created. Energy consumption. So it is particularly about Bitcoin blockchain. There have been a lot of improvement already. Proof of stake is not required, does not require any energy consumption, not much. So it's about mining, and then it used to take a lot of energy. Controls, security, and privacy. Yes, when we talk about security, we talk about blockchain. We say it's secure, but there are a lot of way where if I lose my key, I lose all my data. This is my security concern. If somebody has access to my key, he can see and view my data. That's also a security concern. But that's probably with the period of time we'll find the solution. People will find the solution, and there will be more secure things, but they are more practical concerns actually. Integration concerns. Okay, it is going to be very costly because you see most of the organizations in the industry, they have their own systems, their own applications. So to replace them and get the blockchain on, it will be a big issue for them. So it can be very costly to switch to blockchain. Cultural adoption, it's a decentralized network, while we have already been seasoned to work with the middleman always. So it can be a problem for the people to adopt to it very quickly. And the cost, as I said, there are other disadvantages as well, like anonymity, as we talked about earlier. Uh, it's I mean, if there are anonymous transactions, they can be used for wrong purposes, like drug peddling, like for terrorism. So there can be many things. That's why regulation doesn't want to act immediately on it, because they want solutions to these bigger problems. So we'll have to wait to eradicate these disadvantages from the blockchain and come up with the perfect solution. Okay, few use cases in healthcare. A patient's medical records are often scattered between doctors, clinics, and labs. A blockchain-based, so there are multiple places we run for, and then we go for one ailment. We go to multiple places. We have multiple records. Most of the records we have to keep with ourselves. I've seen my father having a pile of files in the house to keep records of financial things, keep records of medical things and all, legislatory and everything. So that can be solved using blockchains. So I can put all patients' record into a blockchain-based application, and everybody, right from the doctor, clinic, pathology lab, pharmacist, everybody is using that blockchain to access medical data. So it can be controlled for different views. So doctor can view full data, while the pharmacist or laboratory can see required data. It can be controlled through programs. So it will be a good use case, which is already people are using. And then as I put there, there's a research going on at MIT as well, and they're creating a system called MATRAC, and that will integrate all these things with all the healthcare computer setups in the United States, and then it can be broadly used by overall throughout the world. Banking and finance. So a lot of useful application, banking application that we can see. as I have put BankX is one of the example, which is a decentralized app that is allowing to create decentralized financial system for multiple use cases. So when I say multiple use cases, it is creating for funding movies, judicial system, funding other things. I mean, there are a lot of use cases they are creating. You can go to the link and figure out. Proof of stake decentralized app. So as you can see, Tezos is one of the platform for blockchain governance, which will use proof of stake, and it is a self-amending blockchain. So it will allow like Ethereum, you can create your own dApps using this Tezos platform. This is not launched yet, but probably maybe in as per their timeline, it's Q3 of 2018 they are going to launch, and it is said to have higher transaction per second for the blockchain platform. Power generation. So apply to power generation, it will enable homeowners to sell energy back to the grid. I mean, you see this use case. It empowers the user not only to use the energy but to earn for themselves. So if I have solar panels on my roof and I am generating more electricity than I need, I can supply that back to grid and I can earn some money on it. So it's and the blockchain. So if you see the use case, low 3 energy, it's a project which is started in Brooklyn, New York, and where they can decide about their own price on the blockchain, and then they can sell to the grid. Education. So this platform is ready to disrupt the LinkedIn learning. Okay, so this platform, which I have given an example, Live Edu, have a full ecosystem for users and trainers using their videos or their documents for live training. Okay, so the way I'm doing right now using Google Hangout, maybe a year later or 2 years later, I'll be doing it through a blockchain application. Okay, other use cases, angel investing. So you see, it's another startup which is startup, and this is actually working in angel investing field, and they're providing initial funding for other blockchain startups. All these links you can access and you can figure out for yourself what they're doing. Voting, it can be used for voting as well. I mean, it's a big problem, at least for India. I know that a person who is outside India is not allowed to vote because of the vulnerability of the internet. But on a blockchain, it can be done securely, and we can ensure that nobody else is using my vote at all, and they cannot have access to my vote. This can be used, and then you can follow it on Follow My Vote. Smart cities. So this is one of the big project by Indian government to create smart city, and then you see the use cases that can be used for on the blockchain for these smart city. It can be in so many fields: economy, in employment, identity and culture, land use, transportation, energy and waste management, citizen participation, public safety, intelligent government services, housing and inclusiveness, education and health. All these can have blockchain use cases. So you may probably think of one. All right, so with this useful references, so if you want to read a lot more about history of money, you have a good slide up there. For Bitcoin timelines, you can see another reference, then white paper you can reference here, and then for blockchain terminology, there's a Medium article. These are the references that I have used in my document so far. And then question and answers. So I will just for a while stop sharing the screen. Give me a minute. So you can raise your questions if you want now in the chat. I'll just give me 1 minute. And if there are any, I can take them up right away. Anybody? Any question, guys? All right. So I consider that as no. Just before leaving, I will take you to the last slide. Just give me a moment. Just goodbye. I would like to quote Dilbert. So you can read for yourself. All right. So a colorful blockchain would be good. That's what Dilbert is saying. So today you have learned fundamentals of blockchain technology. Thank you very much for your participation. You can follow me here on LinkedIn, Twitter, and Telegram. And we will have our next session probably very soon. Thank you very much all for your participation. Thanks and bye-bye. Bye.